Welcome students to the next lecture, that is we are going to take on support excitation. We are going to solve some problems in this lecture. In the last lecture we have derived amplitude relation for vibrations due to support excitation. So in this lecture we are going to solve a problem. So this problem is like a motor moving with a speed of 100 kilometers per hour has a gross mass of 1500 kg. So we'll write the given. Mass of vehicle is 1500 kg. Velocity of car is given as 100 kilometers per hour. It passes over a rough road which has a sinusoidal surface with an amplitude of 75 mm and a wavelength of 5 meters. So the given is like there is a road surface which is having a sinusoidal surface, and the sinusoidal surface has an amplitude of 75 mm and the wavelength of that particular road is 5 meters. So first of all we'll draw the road surface. So it is like, suppose this is mean equilibrium position or the mean equilibrium position of road, and the sinusoidal road surface is like so. In this is the y or the amplitude which is 75 mm. This distance is wavelength that is lambda, which is given by 5 meters. So this is the road surface, and our motor, it has to, so suppose this is a motor of mass m which is traveling in this direction. Alright, so it is traveling on this road surface. Okay, so next part of problem is the suspension system has a spring constant of 500 Newton per mm and a damping ratio of 0.5. So the suspension system, that is K and C. So it is given that K is equals to 500 Newton per mm. Will convert it into Newton per meters. So it will be 500 into 10 raised to 3 Newton per meters. We will now, given as lambda is 5 meters, then y is given by 75 mm, which is 75 into 10 raised to minus 3 meters. So we have this formula of amplitude of a system which is having a support excitation. So we'll write that formula: x by y is equals to square root of 1 plus 2 zeta r bracket square divided by 1 minus r square bracket square plus 2 zeta r square. So here r is equals to the frequency ratio, that is omega by omega n. So in this formula we have to calculate first omega and omega n. Then for omega n we have the straightforward formula, that is root k by m, which is equals to k is, that is 500 into 10 raised to 3, and the m is 1500. So k is 500 into 10 raised to 3 divided by 1500. So it will be 18.26 radians per second. To calculate the omega, that is frequency of support excitation, that is the road surface. We have to take it into consideration the velocity of car, and also the time period of car to complete a particular wavelength. So here omega will be 2 pi f, that is the frequency in rotations per minute or cycles per second or hertz, which will be equals to 2 pi by tp. Tp is the time period. Then the velocity of vehicle is equals to distance upon time. In our case, distance is the wavelength and the time is nothing but time period, so which will be 5 meters divided by tp, and the velocity is here 100 kilometers per hour. We have to convert it into 5 by 18, that will be 27.78 meters per second. So here 27.78, and the time period will be then 0.179 seconds. So that will be the time period, and from this time period we can calculate this. Omega is equals to 2 pi upon tp, which will be 2 pi upon 0.179, which will be in turn 35.10 radians per second. So that's the frequency of a road surface. The frequency ratio will be omega upon omega n, that will be 35.10 divided by 18.26, which will be 1.92. Zeta is given 0.5, which is less than 1, that means the system is underdamped. So we'll substitute the values of r and zeta into the equation. So the equation will be x by y is equals to square root of 1 plus 2 into zeta is 0.5 into 1.92 r square divided by 1 minus 1.92 square bracket square, then plus 2 into 0.5 into 1.92 into bracket square. We have the value of y also, that is 0.75 into 75 into 10 raised to minus 3 into 1 plus 2 into 0.5 into 1.92 square divided by 1 minus 1.92 square bracket square plus 2 into 0.5 into 1.92 bracket square. So the x will be 0.049 meters, that is 49 mm. That is the value of x, or amplitude of car, that is displacement amplitude. Displacement amplitude of car is equals to 49 mm. That is the amplitude of vibration of car due to the sinusoidal surface of road which is traveling upon. So we will stop here for this time, and in next lecture we will continue the problems on the same topic, that is the problems on support excitation. Thank you.